participation. Well, there is. I lied. I totally lied. Okay, so what we're going to talk about here is types of energy and energy transformation. So, excuse me. Okay, energy can be transformed from one type to another type of energy. All right, so here's an example. You can have electrical energy and it can be transformed into radiant energy. And let's see, what kind of thing would that be? Radiant energy is like heat. So electrical energy that transforms into heat would be what?
A car? Would that be a car?
No, but that would be the electrical energy in the car would transform into like mechanical energy.
Oh.
Okay, because when you turn it on, there's an electric starter, and then the wheels start moving. Okay, so think about something at your house. What do you have that's electric that you get heat from? Heater, blow dryer, good. Stove? I can't think of anything else. Okay. All right, so we just did that one. And so no transformation. This is important. There's always something that's lost to heat, okay, or something that's less usable. So no transformation is 100%. So these are the 6 forms of energy. I guess radiant and heat are 2 different things, but they're kind of the same. So for our intents and purposes, we're going to go with them being the same. Oh, hold on. I can't spell. Okay, so 6 forms of energy: mechanical, chemical, nuclear, radiant, electrical, and heat. These are our 6 forms of energy. There really aren't any other kind of energy. And the one thing that we kind of learned back in, I think it was quarter 2, that all the energy that you make, you can't make any more than there already is. Does that make sense? You can't make new energy. Whatever you have is what there is, and that's in the entire earth. Whatever you have, that's all that there is. All right, so mechanical energy. It's the most familiar form, and that's what we were talking about with the car. You know, you have the electric starter, and then it starts the engine, and things start moving. So that involves moving objects, and that includes sound. So energy may degrade into heat, which is kind of what happens with a car, like when it overheats, right? And this formula is just the formula that we have. You don't really have to worry about it. We're not going to do anything with this formula, but this is total mechanical energy is equal to kinetic energy plus potential energy. And we kind of went over this, I think, in Unit 2. Kinetic energy, again, is moving. Potential energy has to do with height. How high you are has to do with your potential energy. And total mechanical energy is always going to remain constant.
What does that mean by constant?
Always going to be the same. Like if you're talking about kinetic energy and potential energy, if you think about a roller coaster, at the bottom, it's all kinetic energy. As it goes up, so that's the total mechanical energy is all kinetic. As it goes up to the top, in the middle, it's part kinetic and part potential, and that still adds up to the same amount of energy that you had at the bottom. And at the top, it's all potential, and that still adds up to the same at the bottom.
Okay.
Okay? All right, so chemical energy is energy stored in chemical bonds, holding the atoms of a compound together. These are the kinds of things that produce chemical energy: wood, food, batteries, fossil fuel. These all contain chemical energy because when you eat something, all the chemicals that are in that helps you to produce a different kind of energy. Does that make sense? Okay. And wood has chemical energy. When you burn it, produces heat. Okay. Nuclear energy is a form of energy that's stored in the nuclei of atoms. It's released by fission, and that's the splitting of the nuclei of heavy atoms. This is something that we're not going to go into, fission or fusion. It's all nuclear stuff. It's like too much. It's kind of interesting. I mean, if you really want to, when you get, into college, you can do that. Excuse me. Examples of a nuclear energy are the sun, nuclear power plants, obviously, nuclear weapons. Okay? Radiant energy is produced when atoms absorb energy from an outside source and release this energy as electromagnetic radiation. Radiation can be in the form of waves. And we talked about waves, I think, last quarter. Infrared, UV, gamma, X-ray, visible light, radio, microwaves. There's all types of waves, of different kinds of radiation on a spectrum. If you're interested, I can send you a little graph that shows you all the different ones. But that's just what radiant energy is. Okay, electrical energy is energy of moving electrons. So when electrons are separated from positive charges and then forced along a closed path in a conducting material. This conducting material can be copper. It cannot be an insulating material because an insulating material stops the flow of electrons. And if you think about it, the reason that you insulate your house is to keep heat in or air conditioning in, so that insulation stops the flow of the heat through the walls. Okay? All right. Heat, it's a specific form of kinetic energy, energy of moving or vibrating molecules. So when you think of kinetic energy, you think of things moving around. The faster it moves or vibrates, the hotter an object becomes. And you can also think about, like when you run, when you run over time, yeah, you get sweaty, but if you run faster, you're going to get hotter, right? So you're moving faster, you're sort of vibrating faster, and so you're getting hotter. Does that make sense? Okay. All right, so in this picture, we do have these lovely little generators here, and I think next, not the next week that we have, not next week because that's spring break, but the week after, I'm going to see if I can do a lab, or if you're here, you can do this lab. If not, we'll do a virtual lab. So whichever one you want to do. And we have these little generators, and we have things that we can, make a loop, make a closed loop, make a series circuit, make a parallel circuit, and we can light up light bulbs. Yay. So this is what we're going to do next 2 weeks. Okay, so our learning objectives, this is what we want to make sure that we know how to do. Make sure, seriously, I want you to, there is readings. If you've already done this, Morgan, you know that there's the readings that you have to do. It's just, there's not very much of it, is there? No, and it's just the little, when you go into it, it's, I think, page 600. There's a link that you can open. And it's just, I think it's green. Somebody said it's not green. I don't know. Was it green to you? Okay, see? It's either green or blue. Anyway, that's what you're going to read, just the part that's in, it says physics talk. And this will tell you what a closed circuit is. It'll tell you what an actual electrical circuit is. So usually when you need electricity, all you have to do is plug an appliance into the wall. Is that right? Most of the time, right? I agree with that. Most of the time, all I need to do is plug if my phone needs to be charged, I plug it in, right? If I want to keep my food cool, I put it in the refrigerator that's plugged into the wall, right? Okay. If I want a little space heater somewhere, plug that puppy in and I got heat, right? Okay, so usually that's what we have to do. So how is electricity that you use generated? How do you think it's generated? Gabby over there, how do you think it's generated? You can write down an answer. Anything. Just tell me, what do you think? Seriously, is it magic? Maybe it is. How do you think it's generated? When you read, Mark, and I guess you're the only one that has done that assignment so far, but when you read about that, how is the electricity generated?
It moves along through the wire
Right.
and bumps into atoms, causing them to shake, which transfers some energy from electrons to those atoms.
Look at you. Excellent. Power plants, that's true. We get energy from power plants, but that was a really good. Well, you guys should probably turn on your microphones. I like that. Did everybody hear that? Good. Because that's how electricity is generated. Okay, nice. So oil can be used to generate as an energy source. What other sources of energy can you identify? Oil is one. What other sources of energy?
Hydroelectric.
Hydroelectric, good. And what is hydroelectric?
Which is water.
Water, yes.
Running water.
Yep, good. What else? The hand crank, good. What other?
From like animals, I guess, like running or like physical energy.
Physical energy, okay. Anybody? Anybody? Anything? Think of green energy. When you think of green energy, what do you think about?
Solar panels.
Solar panels, good. Yes, good. Wind turbines, good. Anybody else? We did water, we did solar, wind, wood, nuclear, steam. When you boil water, it produces steam, and steam helps turn the fans and stuff in a nuclear plant. Okay, good. They can use garbage to burn. The only thing wrong with that is it really is kind of stinky, so I don't think that they usually use it. Where I used to live in Virginia, there was a nuclear plant, probably about 10 miles away from us. And it was just mostly what they did was they used steam energy. So they had a big lake there, and they used that water, and they boiled that, and that helped to turn the turbines and stuff. Okay, so let's brainstorm. Brainstorm a list of reasons why people do not have access to electrical power from power lines. Why wouldn't someone have electrical power?
Because they don't live where they have it or where they have access to it. Farms.
Some farms don't have it, and that's right. Good, they don't have access to it. I used to live in a cabin that had no access to power lines. So there are people that do that by choice. I did for a little while. Wouldn't do it again. Okay. Actually, one of the things, if you just to think about, okay, electricity isn't so hard to live without. Really isn't, because you have candles, you have lights, you can light fires with wood. The one thing you don't want to live without is, so water. You always want to have water. Okay. So, what sources of electricity would be available for those that don't have energy or electricity from utility companies like Xcel or whatever else there is?
They could make their own.
How would they make it?
Batteries and pennies.
Yep, they could do that.
Kind of things, yeah.
Exactly, they could do that. What else could they do? Again, think about farms. How would they generate electricity on a farm if they didn't have access to a utility company, an electric company? How do you think they would do it? What is one of the main things that when I think about a farm, I always think about this, right? A windmill. So they would use the wind to help to generate power. And again, solar panels. They can use solar panels to generate power. All right. So, if you don't have electricity available, how could you store food and prepare food? How can you store food and prepare food?
Using chemicals, or not chemicals, Actually, I don't know. Scratch that.
Okay. When you think about back in the day, excuse me, and maybe even some of your parents still do this because they like their own tomato sauce, or what kind of things did they used to do when you put things under the house? Yeah, like you have a root cellar, so that would keep your root vegetables, right? What else?
When I think about storing food, like when they don't have electricity, like I just like they put it in jars.
Yes, canning, exactly. That's how you can store food. And canning is, I mean, I used to do it. All right, what forms of entertainment do not require electricity? Dancing, board games. Yep. Puzzles, yes, that's my favorite. Okay, so, you don't always need electricity, guys. All right, if you had a limited amount of electricity, what appliances would you eliminate? What could you guys do without? What could you do without?
A phone charger.
Okay, but then your phone would never be charged. Could you do
Yeah,
without your phone?
if I chose that, maybe,
Okay.
yeah.
Okay, what else? Is there anything else that you could just do without? This is sort of thinking back on yourself. Can I really do
Yeah,
that?
exactly.
Can I really? What about a refrigerator? Could I really not have it? What about a stove? Could I really not have it? So it's just something to think about. Which ones do you use all the time? What about a hair dryer? Could you really do without a hair dryer? Probably, but if it's really that important to you, you'd probably eliminate something else, right? Okay. So top 5 electrical appliances. Top 5. What would you choose?
A refrigerator.
Refrigerator? Everyone agree or not? Yeah? Okay, what else? A stove?
A straightener.
An absolute straightener. Okay. Gabby, what would you do without? Oh, you could do without those. Okay. So we've got 3, but straightener.
That's iffy.
If you didn't have it, you just would be a big ball of fluff, right? What else? 2 more. Let's just come up with 2 more.
Light bulbs.
Could you do without light bulbs?
Yeah.
Good. What would you do instead? Candles. One more. Light bulbs. One more. I'll tell you one I could do without because I never do it. My daughter and my husband does it. Vacuum. I hate to vacuum. All right. So this is a glass bulb, all right, or a light bulb. And these are the kinds of things, and this is something that you're going to have to remember. Again, this is going to be with your assignment. So the whole thing is obviously the light bulb. Inside a light bulb, there's something that's called an inert gas, and that inert gas helps this filament to light up. And this thing in the middle, this round thing, oh, you probably can't see there it is. This round thing is called a filament. These over here are called contact wires. This right here, it's a support wire because this filament is really, really fine and really thin. Right here is the glass mount or the support for all of this stuff. Down here is the base contact. The screw threads are, so you can screw it into the light bulb. There is insulation down here. And then down at the very bottom, there's an electric foot contact. So that's whatever you screw this in, that's what helps to light the light bulb. Okay, so a light bulb has output energy of light and heat. List 5 other electrical appliances that you can think that have input energy of electric and output energy of something else. So I'm just going to put these out there and you tell me what comes out. What about a refrigerator? What kind of output energy does a refrigerator have? Light, because when you open it, you get a light bulb. Anything else? Okay. What about a television? Kind of. It's like a car. What kind of output then does it give? Lights. Good. There's one more kind. It could give off heat if it gets. No, for TV. Light and sound. Yeah. Okay, what about a hairdryer? Heat. What about a vacuum? This one is kind of hard.
That was like sound, wasn't it?
Yeah, it's very good. It is sound. I thought that one was hard. Sometimes heat. Right. Okay, so electrical energy can be transformed into which one of these? A, B, C, or D?
All of the above.
We got one D. Anybody else who disagrees? Gabby, do you disagree? We have a D over here. Okay. Yeah. D is right. You can get all of those things, and that's like from the first or second slide. All right. Which of the following is designed to convert energy into blah, 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 mechanical work? Electric fan, kerosene heater, a flashlight, or a baking oven? Again, think about mechanical or things that move.
Electric fan.
Yeah, it would be the electrical fan because that moves, and when it moves, it generates the air that either cools you down or I guess it could heat you up if it was a heating fan. Okay, choose the correct sequence of energy transformation, and this is in Investigate. So if you read further, because you were so interested in what you were reading in Physics Talk, you could, read further. So with a hand generator, what do you think is the correct sequence of energy? Light, heat to mechanical, mechanical, electrical to light and heat, mechanical to light and heat and light, and electrical and mechanical to light and heat. Which one of these do you think?
I think B.
Okay, we got one B. Anybody else? You can either say it or type it. We got two B's. Two B's. Come on, guys. One D. Is that? Yeah, that's okay. Because you said D the last time, so I thought I was reading it wrong. Okay, Karen, what do you think? D or B? I'm sorry, B. And Morgan says B. Okay, so the correct answer is actually B. It's mechanical because you're turning that crank, and then that goes to electrical, and then that lights up the light bulb, and the light bulb gives off heat. Okay. All right, so here we go. Physics talk. We're going to read the electric circuit, and if you haven't read it, that's okay. But let's think about this. What do you think an electric circuit is? If you've already read it, you already know, so write it down. Think about a circuit. What do you think it is?
It contains power source
Mm-hmm.
and load.
Yep. Okay, we have an answer. It's where energy or electricity flows through, something that energy or electricity flows through. And that's as simple as it has to be. So it's just the flow of that current, the flow of the electricity. Good. So what do you think a closed electrical circuit is? This is another, it's really a simple answer. Think about, what do you think a closed electrical circuit is? Morgan? Okay, so if something is a closed anything, right, it's going to be,
Nothing going on, right? Like no energy in it.
well, if it's closed, it's like, so here's your battery, right? I'm trying to draw a picture here. And then here's your light bulb. Okay, isn't that beautiful? You should see it, Gabby. It's beautiful. Yes, it's like a loop. So a closed circuit, seriously, it's that simple. It's just like a big circle. It's a closed loop, right? Because if it were open anywhere, this light bulb wouldn't light up, right? So it's got to be a closed loop, somewhere where the electricity can flow through. Okay, and so if you want to get a light bulb to glow brighter and you have a hand crank, what are you going to do? What do you need to do? You need to do what? Crank it faster. Okay. So, list all the energy transformation, and this one you really had to read, so I will tell you this, unless Morgan, did you write this down at all? I don't know if you took notes. All the energy transformations needed to light the bulb when using a hand generator. And I know, Gabby, you read this. No? Okay, so I'll just tell you. So if you, right, you are the one cranking it, first off, in order for you to be able to do this, you're going to need to eat something, right? You need to have energy. So it starts with food, right? And the food changes into chemical energy, and that chemical energy changes into mechanical energy, that moving thing. And then that moving thing creates the electrical energy, and then from that you get light and heat, right? So that's the energy transformations in order to get that light bulb to light up if you're using that hand generator. Obviously, if you're just plugging the lamp into the wall, it's something different. Okay, so large turbines are needed to generate electricity for a city. The energy to turn these turbines come from, where do you think? Bunch of different sources. Where do you think, in order to turn these turbines, you need rain, you need water, because it could be hydroelectric, good. What else? Wind, good. Anything else? Steam, good. Water, we said. Wind, we said. Steam, that's good. Also, you need to be able to burn something to make the steam, right? So oil, gas, coal, wood, something like that. Something to burn to heat up the water for the steam. All right, good. All right, almost done. We're going over and I don't like that. So a light bulb has what in its glass, inside that glass bulb? What is that? Filament, good. And it also has two supports, right? Those supports, what were they called? I can't remember. But it also has those on one on each side of the wire. All right, one wire is connected to bottom and the other wire is connected to the side. All right, and something, and this again, this is in the reading, are safety measures to prevent fire. So think about this in your house. Everyone has this. If you have electricity in your house, you have this thing.
Are you talking about the thing on the ceiling?
It's usually, mine is on the outside of my house. Sometimes it's in the basement of your house. These are things that,
Electric motors?
not motors, these are things that will burn out so that, you know, if your electricity, if you get overloaded in your electricity, these things blow.
A fuse box.
Fuse, yeah. So fuses are safety devices in your house so that, you know, that is one thing that can prevent a fire. So it says, okay, you have too much electricity here. I'm going to blow it all out so it doesn't start a fire. Okay. And that's it, guys. Thank you so much for coming. Does anybody have questions? No questions? All right, that's it. Again, if you are here, go into the webinar part and just say attended and you get your 4 points for coming. And if you're not here, I'll put up a question and you can answer it. All right, that's it. Thank you so much. You guys can go. I know you're excited to get back to whatever you were doing. Thanks, Gabby.
Oh, I missed some minutes. Can I talk to you about this?
Sure.
About the webinar. But my only concern is because last quarter I did pretty bad. So my only concern is that for physics, is it like a subject that builds on itself? Okay, because that was my only worry. Honestly, that's why I haven't started it yet. Because I'm like,
No.
So like, what if I need what we learned in quarter 3 to?
No.
start?
What we learned in quarter 3 was all about waves. Now we're learning all about electricity.
Okay,
So,
yeah. So then
yeah.
I will get to it. So I'm kind of scared, but.
Nope. Good question, but no, you don't need
I'm
last
so
quarter.
worried about it.
Yeah. So what happened last quarter?
Oh, it's because it's just a bunch of personal drama in my life.
That sucks.
I know. Now that I'm like 5 months pregnant, now I'm just like, oh my gosh.
Gotta leave the drama behind and think about you.
Exactly. And I can't let things stress me out because it directly affects my baby.
Yeah.
So
Definitely.
So yeah, but this quarter I'm like, okay, I can't let it affect me.
Right.
Because I have to graduate. You know what I'm saying?
Right.
So.
Right.
But yes, this quarter I will definitely be on it.
Good. I can tell you could do it. I mean, I was looking at your math stuff and it's all